In this video, I'll go through some examples of calculations with quadratic equations. So a quadratic equation has this formulation: y equals a times x squared plus b times x plus c, where a, b, and c are constants. If that first constant in front of the x squared, a, is negative, then the quadratic function has a maximum, and that maximum is at the value x equals minus b over 2a. Conversely, if a is positive, then the quadratic equation has a minimum at that x value minus b over 2a. Another feature of quadratic equations that's important in practical terms is the values of x that give rise to y equals 0, and these are called the roots of the quadratic equation. And there's two ways to find the roots. One is just to use the quadratic formula, which is x equals minus b plus or minus square root of b squared minus 4ac, all divided by 2a. That's going to give you two values as long as b squared minus 4ac is non-negative, and so one value will be minus b minus that square root over 2a, and the other value will be minus b plus that square root divided by 2a. If it's possible and the quadratic equation here factors nicely, then that can be a more straightforward way to find the roots, and factoring will give rise to an equation that looks like this. There'll be x minus the first root times x minus the second root, and possibly a constant, which doesn't really matter for finding the roots. On a graph, this is what these ideas look like. So in the top graph here, I've drawn what a quadratic equation looks like when a is less than 0, that constant that multiplies the x squared term. So in that case we have a maximum, and that maximum comes when x is minus b over 2a, and then the roots are when y equals 0, so they're when they cross the x-axis, when the function crosses the x-axis. So one root here on the left and one root here on the right. The graph below is for a greater than 0, and so here we've got a minimum also at the value of x minus b over 2a, and then the roots here are where the function crosses the x-axis. You can imagine a circumstance either if we have a maximum where the maximum occurs below the x-axis, and then we wouldn't have any roots, and that's occurring because b squared minus 4ac is negative, and we can't take the square root of a negative number, so then we don't have any roots. Conversely, if we had a greater than 0 and we had a minimum, that minimum could conceivably occur above the x-axis, and again that's because b squared minus 4ac is negative. Okay, so let's work with a couple of examples to see how this all plays out in practice. So let's start with this first example here, y equals minus 0.08 x squared plus 12x. So we can see right away that a is less than 0, so that means that we're going to have a maximum. And where's the maximum going to occur? For which x value is going to occur at minus b. So b in this case is 12, so I'll have minus 12. And then divided by 2a, a is minus 0.08. So 2 times minus 0.08. So if we calculate that, we're going to end up with a positive number because we've got a negative number divided by another negative number, and it actually comes to 75. And then how about the roots? So let's use brute force first of all. Let's use the quadratic formula. So it's easy to make mistakes here. So best to go slowly. So minus b. So remember b was 12. So I've got minus 12. And then plus minus square root. And then we've got b squared. So minus 12 squared. I'm just going to write 12 squared because it's the same thing. And then we got minus 4a is minus 0.08. And then c, well, what is c? Well, we don't have a constant term in our equation, so c is actually 0, which simplifies things considerably. And then divide that whole thing by 2 times a is minus 0.08. So what do we have? So inside this square root, this part, this second part, the 4ac part, is 0 because of c being 0. So we're just going to have 12 squared. So there's 12, the square root of 12 squared is just 12. So we're going to have minus 12 plus or minus 12 divided by 2 times minus 0.08 is minus 0.16. So we're going to have two roots here. One is going to be 0 because we're going to have 0 over minus 0.16, which doesn't really matter. And then we're going to have minus 24 over minus 0.16. So that's going to give rise to 0, and 24 divided by 0.16 comes to 150. Okay, so I could do a quick sketch of what this looks like, because we know that the maximum occurs when x is 75 and the roots are at 0 and 150. So if I draw my graph like this, so 0, that's going to be one root, 150 is going to be the other root, and then in the middle we've got 75. The maximum is always going to occur in the middle of the two roots, so that's one way to check that you haven't made a mistake. I mean, you might still have made a mistake, but at least you've got that part right. So we're going to have maximum here. It's going to go down through the two roots. Okay, so there's our function very roughly. Okay, let's look at the other example. So in this case, we've got y equals 2x squared minus 8x plus 6. So a is positive. So that means we're going to have a minimum for this example. So our formula for the minimum is minus b over 2a. So minus b in this case is minus 8. And 2a is 2. So we're going to have 8 over 4, so we're going to have 2 as the minimum. And then let's use factoring this time, because it's a bit cumbersome using the quadratic formula, and it's always good to quickly check and see if we can factor the quadratic equation easily. If we can, then that's usually quicker than using the quadratic formula. If we can't, then we obviously have to use the quadratic formula. And factoring is only going to work if you've got integer roots. But turns out we do in this case. So let's just write down the function again. Okay, so we want to be able to write it as x minus something times x minus something else. and possibly a constant in front. So we can pull out the common factor 2, and then we're going to be left with x squared minus 4x plus 3. So x squared minus 4x plus 3, that does factor nicely into x minus 1 times x minus 3. Just check. So we're going to have minus 1x minus 3x, going to have minus 4x times the 2, so we'll have minus 8x. And then for the constant, we've got minus 1 times minus 3, so we've got plus 3 times 2 comes to plus 6. And then the x squared term is just 2x squared. So that works. So that means if we set that equal to 0, then x either equals 1 or 3. Okay, so this function's nice and easy to draw. It's going to be a minimum, and so we'll have 1, 2, 3. So the minimum occurs at x equals, the minimum occurs at x equals 2, and then the roots are at 1 and 3. So it's going to look something like this. I'm going to draw the minimum a little higher up actually. It's not the best quadratic curve in the world, but it'll do. So that's what this function looks like. So there's a few examples of working with quadratic equations.